Hi, I'm going to show you how to do scripting in Bash as part of the course called NAISS Intermediate Bash and Linux. In this session we're going to write some Bash scripts. We're going to use a book on it. We're going to write a script that uses user input, variables, an if and a for statement. Why use scripts at all? That is a good question. The answer is that scripts allow you to run your bash commands in an easy and reproducible manner. Because scripts are text files that can be run, and if you put the bash commands there, you would type in your terminal, you copy paste them there and run it. Suddenly you have something that is reproducible. So the spelling of bash and bash differs with a capital B, it's the programming language, and with a lowercase b we mean the program that interprets the bash programming language. Let's start with the exercise. In the exercise we're going to use this book. It's free and open and it fits the course well. So let's take a look. So we see already to the left there are 9 exercises, a conclusion, and so let's just go through them. And to do so I'm going to keep the exercises at the left of my screen there, and I'm going to keep the book at the right side of my screen. There we go. It looks like this. Let's read it. Read the text. Let's start with a new file with .s. Each exam here we could create a file called tef.doyos. To create that file we can use the touch command. Sure, we can touch to create a file. Then we can edit it using nano. You can use any editor there, I guess. In order to run it, the first line of the script must indicate the absolute path to the bash executable. Sure. Alright, that looks a bit weird. It's called a shebang apparently. All that the shebang does is to instruct the operating system to run the script with the so it says run using this. Bash not always there, maybe not on Linux system. Then you may want to use this. Alright, so then run with this, I guess. Sure, we've read it. Let's take a look. Create a file called greeter with a shebang following that chapter. Alright, so we can do this. Greeter, that's I think all we need to know. Create a file called greeter with a shebang. Okay, sure. So I'm going to put a terminal at the left. We're going to create a file called greeter, touch greeter.sh, I think it was. There. And now we're going to nano greeter and we're going to add a shebang. I'm already going to copy paste this thing. There is the terminal there. Bam. Paste. Ctrl O to save. Enter. Ctrl X. There. We have a file called greeter. There it is. So I've done this. Create a file called greeter with shebang following that chapter. Sure. Touch. I've done that. I've added that. And if it doesn't work, use that. Sure. Well done. Exercise 2. Read the text at chapter 3 Hello World. So I'm going to copy paste this link to here. There. Let's read it. Once we have our file created, we have called it greeter. We have the shebang. We're ready to write our first Hello World script. Open it and add this line of text. Save the file and exit. Sure. And after that, make it executable by doing chmod on the name of the file, and you can run it like that. Another way to run the file would be bash on the file name, sure. You get the same output. Okay, sure. Putting a script together is useful once you have to, yeah, sure. Let's do it. So it has to say hello world, and we need to make it executable. So I'm going to copy paste this line to the terminal. I'm gonna nano on greeter. So to start the editor, paste it here. I'm going to save with Ctrl O, press enter for the same file name. I'm going to press Ctrl X to exit, and I'm going to do chmod plus X to greeter there, and I'm probably it should. Bam! I did it. Did I do the exercise? When it runs, it should show hello world on the screen. Well, it does. It is exactly what I did. Next, exercise 3. Read the text at chapter 4 bash variables. So I'm going to copy paste this text here to take a look and to read it. Bash variables. So we can use a variable like this. Then echo dollar the name of the variable. Sure, so this is a name, and here we do dollar name. Echo, this is better apparently. And include a variable in it again. I'm using the open file. Nano, adding a name. Store the name, and then hide their dollar name. Okay, sure, we can do this. We can do multiple variables. Sure, save it and run it again. You see the screen. Note that if you don't necessarily need it at the end of each line. Okay, we don't need to add a semicolon at the end of each line. We've never done this, so we're not going to do it. You can also add variables in the command outside the bash that can read its parameters. Okay, I'm not going to do that. Right, hello there, $1. So if you run it like this, Bobby and Buddy, then $1 will be, Bobby will be turned into $1 and Buddy $2, I guess. Dollar apostrophe are all the input arguments. Sure, hello there, 1, 2, all, sure. Okay, let's see what the assignment is. Modify your bash script called greeter in such a way that it uses 2 variables. Sure. So I'm going to use mousepad on greeter. So mousepad is my favorite editor. It is a very simple one, but I'm going to use this one. And now we need to have a greeting which should have the main value hello. Greeting is the main value is hello, capital H there. And the name should have world. Sure, name is world. When it runs, it should still show this. Okay, so then it's dollar hello dollar name, and now it should run the same thing. Let's take a look if it works. Go to the terminal. Bam, that's exactly the same, but now I do use variables. Exercise 4. Counting files. Bash can store the output of other tools in variables. Write a script that counts and shows the number of files in our current folder. Create an executable script called count files. In the script, create a variable called nfiles. Initialize it like this. Okay, so nfiles is and then the result of this bash command. Running the script should show you have the files, where nfiles is the number of files. Sure. Run the script to verify. Okay, I can do that. So first we're going to create a file called touchfiles.sh. I'm already going to make it executable. Gmod plus x count files. Now we're going to edit it, count files. We're going to start with the shebang bin bash. Okay, copy paste this line to my script. There. Now it should show this. Back to the script. So this needs to be echo to put it on screen. Instead of nfiles, it will be $nfiles. $nfiles. Good. I think that's it. Yeah, let's run it. Count files. So I have around 100 something files. Count files. 32 is this correct? There are a lot of folders here. Okay. Yeah, could be correct. 32 things. Yeah, I did it. Next, user input. Read the text there. I'm going to copy the link address, going to put it here. bash user input with the previously defined variable and output with echo name. Sure. I'm going to ask the user instead with the read name. The above and another storage. You can start a variable, so it's just a read name. No dollars there or something. Yeah, or this is like the regular stuff. We can make it come true. A dollar name again. Sure. Let's do it. Modify your bash script called greeter in such a way that the script asks for a name is equal to greeter name world is type that should show again hello world. Okay, let's do it. Mousepad greeter. So sure, you can use any editor you like. So it was read name. That's what I need. And then I should say who to greet. Echo who to greet question mark. Read name. Greeting is hello. Situation is the name for the who to greet. If the name world is typed, should again show hello world. Okay, yeah, let's run it. /greeter who to greet world hello world. Let's try with something else. This name, yeah, works. Let's go to exercise 6, conditional expressions. For this I'm gonna read this chapter. Conditional expressions or conditional constructs are features of program which perform different computations depending on what the process of Boolean condition. Okay, a programmer specified Boolean condition evaluates to true or false. They're used by the double square brace or the single square brace built-in commands that test file attributes and performance. Okay, they do stuff. Here's a list of the most popular ones. File test if a file exists, test if a file exists. And it's a block special file. I have no idea what that is. Is a character special? I have no idea. If file exists and is a directory, only if it's a file, if it's a regular file, if it's a file and the symbolic or so these are file things. String expression, so if a variable exists, if it has a length, if it has a length non-zero, oh, if it's empty, if it's non-zero, if it has a length, if they are equal, they're not equal, so this is a not, less than, more than, this is for numbers, dash equal, dash ne. Okay, those are for numbers apparently, and here we can combine them. Okay. Exit status operator returns through the command successfully without any errors. Okay, so this, if you have like a file just closed, this is how you get its result. Good. Let's take a look at the exercise. We will modify our bash script called greeter in such a way that when the name Bond is chosen, the program shows is Bond, James Bond. I'll show the regular greeting. So I need to test strings. This one. So I need to check if the string are equals. Alright, so this is the numeric thing, it should be this one. Let's read the next chapter, exercise 7. Read this chapter. There. Bash conditional. So we have learned about some conditionals. We only need to read if and else statements. Sure. The format of an if statement: if something is true, then do this. If your name is Bond, then right. Or the dash Z means if empty, if you didn't say anything. If else, if your name exists, please enter your name. If it's empty, please enter your name. Else say hi. Alright, if someone is someone. Yeah, so if dev dojo, if the name that's red here is equal to the admin name, then whatever. Good. Alright, this is something else. The user ID, like this is a variable from the operating system or from bash itself. I'm going to skip that one. Alright, you can also use elif do that, else do this, and if not, else do that. Okay, and this is it. Now we're going to modify your bash scripts in such a way that when the name Bond is chosen, the program should show this. Okay, good. So we need this line. I'm going to modify greeter. Mousepad greeter. If name is equal to Bond, it should be like double this one. If name is equal to Bond, I'm just going to copy paste this stuff around just to have it. Oh, I can now see it here. Else. And if, oh, it says phi, sure. Let's move my terminal to the right. I get a bit confused. Let's move mousepad to there. If it's Bond, the program shows it's Bond, James Bond. It is Bond, James Bond. Exclamation mark. Who to greet. Okay, I think this is good. Let's run it. ./greeter. Who to greet. Someone. Okay, let's try Bond. Apparently I've made a mistake. Greeter. This is Bond. Syntax error near else. Alright, so we made a mistake. How does the else look like? Mousepad greeter. If that is that, echo it is Bond, James Bond. Maybe it needs to be like name of Bond. That's what Bond is. If that thing is equal to that thing. There. Echo it is Bond, James Bond, else echo. And let's run. Greeter, who to greet, Bond. So there's a problem with the else. Let's see how it looks like. If else phi. If else phi. Maybe at the end of the if. If comma then. Sure. Alright. So don't forget that. If then up. Then do this. Okay, good. Let's run it. Save, close, greeter, Bond. It's Bond, James Bond, and some name. Yeah, works. Good. So we have just ran the conditionals. Now it's time for exercise 8. We're going to talk about for loops. I'm going to copy paste this link here. So for loops in Bash, you're going to read this entire thing. You can use a for loop for stuff in this show the stuff. For example, the user in all the users. I guess it splits it automatically by spaces. Show that user. Yeah, I can imagine that. Going through numbers, printing the numbers. A while loop. Sure, we can use while something is true, do something. Here we check while there's no name. Okay, yes, we can keep asking for a name. Until loops. Until something is true, do something. Sure, let's see if we need it. Continue and break. So we're going to go to the next loop. You use continue. It tells your bash to stop the current iteration of the loop and start the next one. Okay, we have continue. Skipping number 2. Okay, let's continue. All right. We can also use break. All right. So there's a break somewhere here. Yeah. Here you can break out of a for loop. Let's do it. So I'm going to put my trusty terminal here. Create a new bash script called greet names. Sure. Touch greet names chmod plus x greet names. So it's executable. Mousepad greet names. Put it in the right. Put a shebang here. Bin bash. Ask who to greet with the text. Who shall I greet? The expected input names are names separated by spaces. So read names. Echo who shall I greet? There. Greet all those people. What is this for? Name in dollar names. Do done. Echo dollar name. I need to say hello. Sure, we can do that. Hello name. Sounds good. Let's run it. Greet names. Anna, Bernd, Cindy. Bam! Works! Next step. For loop with bash commands. Instead of iterating over name, we can iterate over something useful instead, such as the output of a bash command. Create a new bash called show files. Okay, let's do that first. Touch, show files, chmod plus x to make it executable. Show files. Edit it. Show files there. I'm gonna add a shebang. Bin bash. Store the output of ls in. Okay, file names is $. Store the output of ls in a variable called file names. Per file name show I find a file call. For file name in $. File names do done. Echo I found a file called file name $. File name exclamation mark. Yep, let's run it. I think I've done everything now. Run the script to verify. Show files. There! I have done it, and that means I have just showed you all the exercises. Alright, now it's time to go over the more advanced questions, just to repeat, to go a bit deeper about bash. So what is the difference between awk and bash? So they are both programming languages. They just have different things to write things. They are different programming languages. What can bash not do? Well, as a programming language, it is Turing complete. It can do everything, but what it does need time and space to do this. So it cannot run computations at any speed. It needs memory. So some calculations are still infeasible, but besides that, it can do everything. When not to use bash. So this answer is a bit of a gray area. I would say when you don't need to, because bash shines at problems of low and intermediate complexity, because it can connect all the bash commands. Like with bash, you can run a lot of commands, you can change them together. That's what allows you to solve problems of intermediate complexity, because you can use all the tools with a pipe. If you want to do harder problems, use a modern programming language instead. Sure, you can do everything in bash if you want, but it will be less recognizable. You don't have like libraries you can use. So this is like a recommendation. So for the conclusion is that Bash can do most things one expects from a programming language. A script starts with a shebang, which looks like this. This is how you make it executable. You can run it with ./ at the start. We can use variables. We can store the results of bash things as a result in a variable. We can ask it for input. We can do conditionals, and we can use for loops. So in the next session, bash can do way more, and you'll see this in the next session. But for now, I wish you a very good day. Bye.